Okay, so we've been talking about loops. We've talked about the 3 different types of loops: while loops, do loops, and for loops. Going to delve a little bit deeper into for loops, show you some of the things that can be done. For the most part, we've been looking at for loops that have one initialization, one condition, and one update expression. But we can actually have multiples of those if we so desire. So in this example, we actually have 2 initializations with declarations. So for example, the variable I is declared here in the for loop and initialized to 5. The variable j is declared and initialized to 0. And that both happens inside the for loop separated by a comma. This condition is 2 conditions that are put together with the OR operator. So it actually becomes one condition really. As long as one of the conditions is true, the loop will repeat. And then we have 2 update expressions. So I increments by 1 and j increments by 2. So again, this is just to show you what you can do with for loops. This is not very common. Yes?
When it was just one declared value, you said it was kind of sloppy style to do it inside the for loop. It's just like say int is I equal to 5. When you're doing more than one, is it like not sloppy?
It's doubly sloppy, I would say. Yeah, generally speaking, it's better to declare the variables at the top of the section, the method. It's just considered better style. The advantage of doing it that way is that if you need the values of those variables after the loop is over, you can still access those variables. If you declare the variable here within the for loop, then the scope of the variable is limited to the for loop. As soon as the for loop is done, those variables disappear. So you don't have access to those values anymore. And on the opposite extreme, you can have a for loop that is this simple. Let's see. Okay, so the for loop can be literally that simple. Basically empty with 2 semicolons. That meets the legal requirements, if you want to put it that way, for a for loop. So there's no initial condition, no initialization, no condition, and no update expression. What do you think would happen if you created a loop that way? It'd be infinite. There's nothing to cause it to end. So in the real world, you really don't want to do this, but I'm just showing you that from a legal syntax point of view, it is possible. A common application of loops is to calculate a running total. So in this particular example, we have a loop that asks the user for data, and it stores the data in a variable, and then also adds the data to a running total. So every time the loop repeats, the total gets a little bit higher, keeping track of the running total. So let's look at an example of that called total sales. Let's see here. I need to. So here we have the total sales program. Notice we're importing the decimal format class and the JOption pane class. So the JOption pane we know is for dialog boxes. The decimal format can be used in conjunction with dialog boxes to format decimal numbers as shown here. We have 4 variables. Days is of type int, sales and total sales are doubles, and input is of type string. So here we have the input dialog. We're asking the user how many days they have sales figures for, and we're going to store that in this variable days. And that will determine how many times the loop will repeat later. And here we have the beginning of the for loop. So we have our counter variable count is declared here and initialized to 1. Then we have count less than or equal to days. Again, that value for days was obtained from the user, and count is incremented by 1. Each time we repeat the loop, we ask the user for the sales for a day, store that in this variable sales, then we add that value to the running total sales. And that's accomplished with this operator. That should look familiar to you, the plus equals operator. What does that do again? Right. It's a shorthand way of saying total sales equals total sales plus sales. So we're adding sales to total sales, then storing that new value in total sales. So total sales accumulates the values for all of the sales. And once count exceeds the value for days, then the program is done. Another key part of this is that total sales does have to be initialized, as shown here, to 0. Otherwise, we'll get a compiler error. So let's go ahead and run this. So how many days? Let's say we have 5 days of sales figures. Let's say the sales are 2, 4, 6, 8, 10. So the total sales are $30. Questions on that? Why is count initialized to 1 and not 0? You're close. We're starting numbers at 1, and the final number is going to be days, whatever the user input. So it just says an example. Let's say the user chose 3 days. So count's going to start at 1. Then when we increment, after the loop repeats, count becomes 2. That's still less than or equal to days. Repeat again, count becomes 3. That's still less than or equal to days. Repeat again, we go back to the top, count becomes 4. No longer is count less than or equal to days, so the loop ends. So I'm pointing that out to try to help you avoid the very common off by 1 error. So in other words, if we had initialized this to 0, we would have had too many days, 1 more day than the user specified. Likewise, if we put a less than symbol here instead of less than or equal to, we would have had too few days. So those are just examples of off by 1 errors that can occur. So you want to double check your code, test it out, make sure that the loop repeats the exact number of times it's supposed to. If it's just off by 1, that's going to cause major problems later. Any other questions on this example? Okay. Here's what the logic would look like in a data flow diagram for the program we just saw. Here we set our accumulator to 0. Here's our decision diamond. And when that's true, we execute these statements, this one and this one. And we go back up here. We check the condition again. And again, as long as that's true, this will continue to repeat. Once it becomes false, we go down here and move on to the next section of code. Sometimes we don't know how many data points we're going to collect. The endpoint of the data is not known. In that situation, a common solution is to use what's called a sentinel value. The sentinel value is sort of like a magic number that when the user inputs that number, the program will stop asking for data. When choosing your sentinel value, you have to choose something that is outside of the possible values that the user might actually type as real data points. So a common example is to use -1 as the sentinel value. There are many situations in which only positive numbers make sense. So if we use -1 as a sentinel value, that's a good number to use. So let's take a look at an example that uses a sentinel value, soccerpoints.java. So here we have the scanner object. So that tells us we're going to get data from the command prompt. Here's two variables, both of type int. We're going to ask the user to enter the number of points for their team and enter -1 when finished. So that's an important part of using sentinel values. We have to explain to the user what the sentinel value is, because they're not going to know unless we tell them. So this program tells them -1 essentially is the sentinel value. Then we prompt them with the question, enter game points for -1 to end. So we're telling them again what the sentinel value is a second time. So while points is not equal to -1, in other words, while the user has not typed -1, we're going to accumulate the value of points into total points, and then prompt the user again, enter points or -1 to end. And the user can repeat this as many times as they like and hit -1 when they're done. So if they don't know how many data points they're going to enter, this is a good solution. So I'll enter in some numbers here, 4, 5, 6. Now -1 to end. Total points are 15. Excuse me. So some things I want to point out about using a sentinel value is that you do not want to ask another question, and you do not want to use another variable. You want to use the same prompt and the same variable that you're using to collect the data. Okay? We're simply going to check that variable to see if it's equal to the sentinel value or not, and that's done typically in the condition of the loop. Okay. If you type -2, the way this program is currently written, it will accept it and add it to the total score. So what would be a way that we could avoid that situation? Let's say we want to take any negative number as a sentinel value. Right. And what would it become? Yep, that would work. Less than or equal to -1. So now the user types any negative number, that would end the program. Oh, what happened? Oh, it didn't execute the first time. Why didn't it execute the first time? It's actually a very good demonstration. No, I see what you're saying, but no, it doesn't flip around like that. The problem is that this variable points is not initialized. We declared it, and we checked it here, although it should be assigned here. No, that should have worked. Oh, this needs to be. Now we have this backwards. Shouldn't we want this to repeat when points is positive? So it should be while points is greater than or equal to 0. That's the problem. So we had our condition backwards. We want the loop to repeat when points is positive or 0. Right? So while points is greater than or equal to 0, we repeat. If it ever becomes negative, that would cause this to be false. The loop ends. We're telling the user that the sentinel value is -1, but in reality, they could type any negative number, and that would cause the loop to end. Good? We looked at nested loops in the last class, but just to recap that quickly, a nested loop is having one loop inside of another loop. So in this example, this inner loop repeats 10 times for every time that the outer loop repeats. So the end result is that these statements inside of the inner loop will be executed 100 times. Okay, and we saw different examples of that last class. Here's another example, clock.java. So this program has 3 loops nested inside of each other. The innermost loop counts from 0 to 59. Then the loop outside of that also counts from 0 to 59. And the outer loop counts from 1 to 12. So the outer loop represents hours, then minutes, then seconds. And every time the seconds cycles all the way through, minutes increments to the next number of minutes, and so on. So we can see this run, and it's basically a digital clock. The seconds don't, at this moment, correspond to real seconds. Okay, it's obviously moving much faster, but we could change the program, alter the program so that it did correlate to real seconds. And if you've seen those apps from an app store for your mobile phone, there's lots of stopwatch apps out there. This isn't too far from that, especially if you wanted to make one for Android. You can write a program in Java. You can use the Android development kit to take your code and actually download it into your phone and create an app. We've seen the break statement before. Where did we see it before? Very good. In the switch statement. So we had the keyword switch, and then we had several cases. And generally speaking, at the end of each case, you're going to have a break statement to end the case. We can also use the break statement within loops, and it will break out of the loop. However, I don't recommend it. It's considered bad form. Instead, use the native conditions that are available within the loop to end the loop. The continue statement is basically the opposite of the break statement. But again, I don't recommend using it since the break statement is considered bad form. The continue statement also generally should not be used. So to recap, we learned about 3 types of loops: the while loop, the do while loop, and the for loop. They each have their different characteristics that determine when we should use which type of loop. So the while loop is a pretest loop. So we want to use that whenever we have a situation in which the statements may not execute at all, and that can happen. The next type is the do while loop. We want to use that whenever we need the statements to execute at least one time. And finally, we have the for loop, which is also a pretest loop. We want to use that when there is some type of counting variable that can be evaluated. In other words, we know exactly how many times we want to repeat. That's when we should use the for loop. So when you encounter a problem, it's not going to be cut and dry. They're not going to tell you which type of loop to use. It's going to be up to you to understand the problem and then decide which type of loop you're going to use to solve it. Any questions on loops before we move on to file input and output? So Java, as well as many other languages, provides the ability to open, write to, read to other files from within your Java program. So you can basically create text files from within a Java program. And this can allow you to do many useful things. In order to do that, we need the printWriter object. And once we declare the printWriter object, which in order to declare it, we have to give it the file name that it's going to be writing to. Once it's declared, we can then use that object to essentially print strings to the file. It works the same way as the print and print line statements that we've seen with system.out. So before we used system.out.println, when we use the printWriter class, we're going to use the name of the printWriter object that we've created, and then .println or .print. Both of those are available. So in this example, the printWriter object is given a value, names.text, and it's given a name, output file. Then we can use that object name, output file, .println, to write to the file the same way we're used to writing to the command line. When we're done, we want to make sure to close that file. Otherwise, other programs will not be able to interact with it. So here's an example of a program that does that, the printWriter class. It's called FileWriteDemo.java. So we're importing the scanner class, and we're importing the IO classes. These IO classes are what enables us to read and write to the file. We're going to create some variables, 2 variables of type string and 1 int. We ask the question, how many friends do you have, to the user. We store that in this variable numFriends, and that's going to determine later how many times a loop is going to repeat. Then we ask the user for the file name. That's a file name that will be created that we're going to then populate it with the contents. So here's the loop. It's going to count from 1 to the number of friends, and each time ask the user for the name of a friend and then write it to the file using this command, output file.println. When we're done, we close the file and display a message that the data is in the file. So let's go ahead and run this. How many friends do you have? Now, I have more than 5 friends, I promise, but I'm just going to choose 5 because I don't want to sit here and type hundreds of friends. Okay, so 5 friends. What should the file name be? What do you want to call the file that we're going to write to? We'll call it friends.txt because it's going to be a text file at the end of the day. So now it's going to prompt us for the 5 friends' names. So there we've typed some friends' names. Now it says the data has been written to the file. Now the location of the file is going to be the same as the location of the Java program that we're running unless we specify otherwise. So that text file just got created within this chapter 4 directory. So we can browse to that file. See users. And here's the file we created. We can open it with Notepad or TextPad, and there's the contents. Okay. Any questions on what we just did there? It does. It just is not being displayed. That's a setting in Windows Explorer. And I'm trying to remember how to change that setting. Does anybody know off the top of their head? Thank you. Yep. File, properties. There it is. So folder options, view. So by default, Windows says, which setting is it? Hide extensions for known file types. We want to turn that off. Then it shows the txt extension. So that's another pointer, I guess. I recommend turning that off so that you do see the file extensions. By default, Windows has it on, hides all the file extensions. I'm not sure why. But if you have it hidden, then you might rename this file thinking it doesn't have an extension, thus giving it another file extension. So then it becomes friends.txt.txt, one of which will be hidden. So I recommend not hiding the file extensions, make them visible. An exception is when something unexpected happens in a Java program. And one situation in which that can happen is if we try to open a file that doesn't exist. That would definitely throw an exception. Or if we try to write to a file in a directory that has been restricted and we can't write to it, that would also cause an exception. So we can use the throws clause to handle that. And that would go in the header of the program. So this should look familiar, our best friend here, right? And then we add this to the end, throws IO exception. And so that if there is a problem in anything that has to do with input and output, it would throw an exception. So I'm going to skip ahead a few slides to an example. Read firstline.java uses that throws clause. So here it is, the throws IO exception. And so this program prompts the user for the name of a file, and it will open the file, read in the first line as shown here. Okay, string line input file dot next line. And then it will display a message that says the first line of the file is and display the line. Then close the file. So if we give it a file name that exists, then this will work as we expect it to. So there it is, displayed the first line in the file. However, if we give it a file name that does not exist, we get the exception. Okay. To read data from a file, we need the file class. We create an object of type file. Then we create an object of type scanner. So it works similarly to getting data from the keyboard. So we need that scanner object to make it work. And we give it the name of the file inside the parentheses. Once that's done, then we can read data from the files basically in the same way we would from the command line. So for example, if we have the file names.txt, and that is stored in this scanner object named input file, we can then use input file.nextLine to read in a full line of text from the file. So similar to the way that we got text from the command line and we used the scanner object for the keyboard, this does it from a file. And we saw that example already. Questions on that? We can also detect the end of the file with this has next method. So in this example, we're continuously checking to see if the file has more information with this has next method. And if it does, we keep reading lines of text using the next line method. And then when it's done, the loop simply ends. If we just kept reading next line without checking to see if there's another line to read, that could result in problems. So that's why we need to check to see if there's more information to read before we actually try to read it. So here's an example of that, file readdemo.java. So this program uses a loop to continuously check to see if there's more information in the file, and then we'll display the information one line at a time to the command prompt. So I'll use a file that I know exists, and there it displayed all the contents of the file. It doesn't have to be a text file, by the way. It needs to have text in it for this to work properly, but it doesn't have to have the txt file extension. As an example, we could use any file in this directory, such as clock.java, and it would read in that file and display all the contents. If the file doesn't contain text, then this hasNext method would not work properly. In other words, if we tried to give it the name of an image file, that would probably cause problems. Our last new topic for today is random numbers. Who can tell me what a random number is? Okay, 7 is a random number. What's a more general definition? Basically, you don't know what it's going to be, right? It's some unknown value that's picked out of the air. Some real-world examples of random numbers would be flipping a coin. Okay, you could represent that as a random number with a value of, say, 0 or 1, where 0 might be heads and 1 might be tails. Or rolling a 6-sided die is another common example. That will generate a random number between 1 and 6, a whole number. So those are random numbers. So most programming languages do provide a way to generate random numbers. And in Java, it looks like this. We need to import the random class. Then we create an object of type random. And then once we have that, we can manipulate it in all sorts of ways to get numbers in the range that we want. So we've seen these methods before: next double, next float, next int. And these will round numbers to the particular data type that we've specified. We can also use next int and then give it a value inside the parentheses. This will modify the random number so that it's within a specified range. The range will be 0 to n. So let's look at an example. It's probably the easiest way to understand this. Roll dice.java. So this program simulates the rolling of 2 6-sided dice. We have 2 variables of type int. We have the string that we use to see if we want to keep rolling dice. Here's our random object. It's named rand. And then here's the key part here. Die1 equals rand dot next int 6 plus 1. So the way this works is this part generates a random number actually between 0 and 5. Okay, that's what that 6 signifies. It means it's going to generate a number between 0 and 5, including 0. What we want is a random number between 1 and 6, so that's why we have to add 1 to it. Same thing for die 2. Then we display the individual values of the 2 dice as well as their sum. So we'll go ahead and run that. So our first roll, the values are 6 and 4. The sum is 10. We can roll as many times as we want. 1 and 5 is 6. 6 plus 2 is 8, and so on. So this clearly simulates the rolling of two six-sided dice. Now, if that is our goal, to simulate the rolling of two six-sided dice, do we need to do it this way, or can we instead generate a random number between 2 and 12? Because the possible range of values of rolling two six-sided dice is 2 to 12. Okay. Could we just have one random statement that generates a random number between 2 and 12? Would that be equivalent?
Yes and no.
Yes and no. Okay.
Because
In computer science, we can't have yes and no. We can have one or the other.
in a real world object, you don't have two separate that to be able to program. So I guess you don't get the feeling that you have two die in front of you with the program, I guess. Instead of just rolling one dice.
Okay, so, but are those the same thing? Let's say we had a 12-sided die that with numbers 2 to 12.
Be the same.
Okay, so then that would be the same as generating a random number between 2 and 12. But if we're trying to simulate the rolling of two six-sided die, is that the same thing as generating a random number between 2 and 12?
As long as the instances were like each time that you pick numbers between 12, that it was unique, right? Like it wasn't based on each other. Because every time you roll the dice, you have the exact same probability of getting it, right? But if you pick two numbers between 2 and 12, they both have to be like you have to run it uniquely two times. That's what I'm saying. Right? So if you like pick two good numbers between 2 and 12, but it couldn't be.
Well, no, we want one number between 2 and 12,
Oh, well, that should be
right? The situation is we're trying to simulate rolling two six-sided dice. The way this program does it right now is it generates a random number between 1 and 6, then another number between 1 and 6, and adds them together. What I'm proposing is, can we make this shorter by generating a single random number between 2 and 12? Is that equivalent? All right, let's take a vote. Who thinks they would be equivalent? 1, 2. Who thinks they would not be equivalent? 1, 2, 3, 4, 5, 6, 7, 8. Okay, most people say it's not equivalent. So I would agree it's not equivalent. Why is it not equivalent?
you get the probabilities of the same number on each dice.
Tell me more.
Ones, as opposed to 1 out of 12 for number 2.
You're on the right track. So here's why. When we're adding the values together, the probability of getting certain sums is different than other sums. So from a probability point of view, if you're rolling two six-sided dice, the number you're going to get most of the time is going to be 7, because there's many different ways to add up to 7. You can have 1 and 6, 2 and 5, 3 and 4, then switch it 4 and 3, 5 and 2, 6 and 1. So 7 is going to be the most common roll. As we move away from 7, the rolls become less probable. So 8 and 6 will occur fewer times than 7, and so on. When we get to 12 or 2, there's only one way to add up to 12. You have to roll 6 on both die. So that's the least common roll. And on the other side, there's only one way to add up to 2, and that's to get a 1 on each die. That is also the least common roll. It's tied for 12. So it's a little lesson in probability, but as programmers, we have to be aware of that. that not all random numbers are created equal. Basically, is the lesson there. So even though the range is correct, if we tell it to generate a random number between 2 and 12, the probability would not be correct. It would not be an accurate simulation. All right, that finishes that. How much time do we have left here? 7 minutes. All right, let's try and decide if we should do this in groups or individually. I'll make a vote. Who wants to do a group project? Who, as opposed to working individually? If you want to do work in a group, raise your hand. If you want to work individually, raise your hand. All right, individually. Here's the problem. You're going to create a program that will prompt the user for the number of times to roll 2 6-sided dice, and then save those values in a file. So basically combining everything we learned today. So I'll type that here. Prompt user times to roll 2 6-sided dice. Store those. And you should prompt the user for the file name too. Okay, so I'm not expecting you to finish today in 5 minutes, but get started and we'll finish it in class tomorrow.